We're starting with the idea of displacement versus. Um, I don't like how thin that is. Let me give me myself a little bit more thickness. So, wow, that's very thick. But anyway, we're gonna go for projectile motion. We all know what projectile motion, but this is considered distance. I'm using basically a mouse. I'm not actually using a tablet, so it might be a little bit scuff. But we call it ds. When we do something linear like this, that is what we call displacement. Why am I saying that? It's because it confuses people, and it confused me for a long time. But I realized I never really explained this in a video before. This over here is what we could say as displacement. I don't like how bad that looks. Let me go into a little bit more like somewhere like this so it actually looks good. So we'll draw this again. So we have a projectile motion like this, and this over here is a ds. Now, if we were doing the x direction, like just the x direction like this would be considered dx over here when we do something over here, which is displacement in the x direction. Now, displacement in the y direction would be considered this. But I didn't draw this high enough, so we'll be going to do this. Um, so what does that mean? It means that over here is what displacement is if I was to choose this point, but this point looks to be about over here. So what that means is that from the origin to over here, because displacement need an origin or datum, which we decide, and if the datum is over here, then this is a distance, but that means that when we start the projectile, this is a bad datum because when the projectile starts, this is the displacement, which is kind of really awkward. Um, so in that sense, we got something, right? So let's start again. We have a projectile motion. I mean, it doesn't have to be projectile. It could be like something like this, for all I know. Then we know over here, if we cut a little bit over here, this is a ds. And if we were to calculate something on this point and say, what's the displacement, you wouldn't care about this part. You wouldn't get the arc length. You would get the x over here, the direction of the dy over here, which is no longer dy. It would be considered just y. Over here, you would consider this just x. And then you would get the Pythagorean theorem up. But do I like that explanation I just gave out? Not really. But that is generally what you're supposed to think about when we think about something like this. But I think I can make a better one with yeah, that's better. And then we can say ds is like this. I'm repeating it 3 times until I get a better idea of if this. I don't like how I explained this, so we're just gonna do it again. Over here, this distance over here is what we call a displacement. This over here, the arc length over here, is what we call arc length, or actually distance technically, for a projectile motion thing. So that's what I'll say. Do I need to explain more? No, I don't think I do. But it gives a general better idea of what I was trying to say. This is a normal way to look at it. Now, why is this important? Well, in engineering, projectile motion is complete garbage. Basically, almost useless unless you're doing weaponry, like a weapon like this, and then you're guiding something like this with something like a force balance with the quad copter like this, where they fly. Uh, I actually calculated the system for this long time ago. I forgot the answer, but it's something like x dot and then theta dot, and then you make a matrix of that. I forgot, but I did that before. But what's important about this is that if you have a satellite going like this or something, I forgot your scanner. I believe it's a scanner. You scan. There's 3 ways to scan. I forgot really, but I think there's a scan like this, if I remember correctly, a strip scan, and there was a scan like this with a little dot in between, and it just goes up like this, and the scan stinks. I know my explanation is a little scuff. Honestly, this is the scuffiest. This is scuffed a little bit. Why am I doing this? Is because before I was going to make this video a long time ago about displacement versus distance because I wanted to, but I totally forgot to do it. So while I remember, might as well do it, right? I'm a dumbass. Anyway, what else am I forgetting? Did Bernoulli before? As you can see, this is a complete mess of shenanigans. I don't know what the hell I did some of these for. This looks like a tensor I was doing. This looks like Bernoulli equation. This looks like some weird Bernoulli. Oh, this is just a derivative, figuring out how to do that. Oh, I remember this. This was how you figure out the if you want to figure out the product of a spin. Basically, this is, I believe, irrotational. Irrotational means a vortex like this, but the velocity profile is like this. Rotational is usually like this is the most basic one. There's other ones like this, but this is rotational everywhere. I mean, technically, it's only rotational for not the origin. If you make something in a circle like this, what happens is that you have circulation, which is this. Now, for some reason, some textbooks have it, so I believe it's VDX, right? Is it dot? I don't remember. No, it's yes, it's dot. And then you can use what do they call it? Strokes theorem opposite, I believe. No, was it Stokes theorem or no? I don't remember. I'll remember soon. Anyway, first of all, I'm just gonna do something real quick. Like, I wonder if I can just delete it like this. No, it doesn't delete like that. Well, I'll just try. It doesn't really matter how I scan it. Anyways, yeah, I think we're good. We don't have much more to say.